Hello. Somewhere off in the distant world of physics problems, there's a platform. On this platform is a box of mass m. Now the platform has a coefficient of friction, static friction, of mu sub s. The platform is tilting so that the angle between the platform and the ground is constantly increasing. Our task is to find the angle at which the box begins to slip. So, intuitively, you should be thinking about force, Newton's second law, and friction. Just as soon as you see a problem with this premise, that should come to your head. And the first thing we need to do to solve a problem like this is to draw force diagrams, to organize our thoughts about the forces that are acting on the object. Here's the raw force diagram of the box, with gravity, as always, acting down, normal force acting perpendicular to the surface, and the force of friction preventing the box from sliding down the surface. Now, broken up into components, we have the gravity, both broken up into horizontal and vertical components. Again, friction and normal force. And we're using a standard coordinate system, meaning that up is positive in the y direction, as is right in the x direction. So now that we have our force diagrams and we have all of our thoughts organized, we can write Newton's second law for the x-axis and the y-axis. In the x direction, we have gravity acting to the right, mg sine theta, minus the force of friction. And since this is the angle at which it just begins to accelerate, meaning the maximum at which there is no acceleration, a is 0 and ma cancels out, resulting in 0. Simplified, this comes out to the force of friction is equal to the horizontal component of gravity. Now, we want to find the force of friction, which can be done using the simple formula for the force of friction, which is it's equal to the normal force times the coefficient of friction. To find the normal force, we just go back to our Newton's second law for in the vertical coordinate and solve for the normal force, plugging in the forces that we see in our force diagram. We find that the normal force is equal to the vertical component of gravity, and we plug that into the equation for friction, plugging it back into here. Now, the only unknown we have here is theta, which is what we're trying to solve for. Since both sides of the equation are multiplied by mg, the force of gravity, both of those cancel out, and we are left with the coefficient of friction times the cosine of theta is equal to sine theta. Now, we can simplify this by dividing both sides by cosine. We come out with sine over cosine of theta is equal to the coefficient of friction. Well, if you remember your trigonometric identities, sine theta over cosine theta is equal to tangent theta. We plug that all back in, we got tangent theta is equal to the coefficient of friction. And to solve for that, we just use the inverse of tangent, and we find that the angle at which the box slips is equal to the arctangent of the coefficient of friction.